Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting and finishing the arithmetic section from Meet 1 because it's a very short section, so we only have a little bit to cover. We've already learned most of it, so let's go ahead and dive right in. So arithmetic is all about solving equations. And in equations, we have a certain order in which we execute operations. That's what we call the order of operations. So this is the order of operations here. We call it PEMDAS. It stands for parentheses, exponents, multiplication and division, and then addition and subtraction. So what that means is when you have an equation, you have to do whatever's in a parentheses first before you do exponents. And then you do whatever's has an exponent before you do multiplication and division. And then finally, you do everything that has multiplication or division before you do addition and subtraction. So a good way to remember PEMDAS is, please excuse my dear Aunt Sally, because each word starts with the first letter of each operation that you have to do in the order of operations in order. So please would be P, and that's parentheses, E would be exponents, M would be multiplication, the D and dear would be division, A and aunt would be addition, and S and Sally would be subtraction. So please excuse my dear Aunt Sally. And then there is one thing about the order of operations that neither PEMDAS or please excuse my dear Aunt Sally, if you're remembering it that way, convey, is that although we say PEMDAS, multiplication and division and addition and subtraction are equal in order, which means you do whichever comes first. So if you have multiplication and division in an equation, you don't always do the multiplication first, just whichever comes first out of the two of them. And same for addition and subtraction. You don't always do you don't always do the addition first, you just do which comes first out of the two of them. So to explain this, I have an example equation here where we have 5 minus 2 plus 4 times 3. So our order of operations tells us that we need to do 4 times 3 first because it's multiplication. So 4 times 3 simplifies to 12. So now we're left with 5 minus 2 plus 12. Now, if you're thinking PEMDAS, you know that the A comes first for addition, but the note says that we only do addition and subtraction in whatever order comes first. So since we do subtraction first here, or it comes first in our equation, we actually do 5 minus 2 first. So 5 minus 2 is 3, and then we add that to 12 because we're left with 3 plus 12, and that simplifies to 15. And then I also have a few tricks here to simplify solving equations. They're very specific, so you're not going to see them very often, but you might see them in some questions. So the first is grouping. So grouping is when you look for alike terms, which are terms that have the same value in an equation, and combining the same operations done on them. So to explain that, I have an example here. So in my example, my equation is 917 times 34 plus 5 in parentheses, plus 83 times 34 plus 5 in parentheses. So the way we would use grouping is we look for alike terms, and that's defined as terms that have the same value. So we have 34 plus 5 twice in this equation, and it's in parentheses, so we have to do it first. So we know that they're both going to simplify to 39, so they both have the same value, this section and this section. So what we can do is combine the same operations done on them. That's what our definition says. So the first operation done on the 34 times 5 is multiplying by 917. And then you add the other operation being done, which is multiplying by 83. So you keep the symbol here and you add 97 and 83 and multiply that all by 34 plus 5. So you don't have to multiply them each individually. And the reason that that can be helpful is because in the case that they add up to really nice numbers, so in this case 917 and 83 add up to 1000, you can just multiply it a lot more easily than multiplying 917 by 39 and then adding 83 times 39. So grouping is when you look for alike terms, which was 34 plus 5, and combine the operations done on them. So we have 917 times 34 plus 5 plus 83 times 34 plus 5. So we just do 917 plus 83 times 34 plus 5. And then the next one is square terms. So this is very specific. You're not going to see it very often, but you might. So an equation in the form of a squared minus b squared can be simplified to a minus b times a plus b. So I also have another example here. So if my equation was 27 squared minus 23 squared, well here I only have two square terms, 27 squared and 23 squared. So I can simplify it to whatever those terms are, minus each other and plus each other. So 27 is my first term and 23 is my second term because they're both being squared. So I can simplify to 27 minus 23, like a minus b here, and to 27 plus 23, like a plus b here, because 27 are my a and my b. And that's useful because you don't actually have to square each number and subtract it. You can just subtract them and add them and multiply that by each other, which leaves us with 4 times 50, which is nice and easy, and that's 200. So now, based off the order of operations and just general arithmetic, we're going to do a practice question. So here's the practice question. If you want to try it, I'll give you a few seconds to pause the video now, and then I'll explain the answer. So the correct answer to this question was 152. So the way to solve this question is to use our order of operations to do what we need to do first, and then just simplify it down from there. So our order of operations is PEMDAS: parentheses, exponents, multiplication and division, addition and subtraction. So first we need to look for any parentheses that we have in our equation. Well, we have some right here, and we have some right here. Two sets of parentheses. So in our first parentheses, we have 4 to the power of 2 divided by 8. So exponents, which is the E in PEMDAS, comes before division, which is the D in PEMDAS. So we need to do 4 to the power of 2 first, before we do divided by 8. So 4 to the power of 2 is just 4 times 4, which simplifies to 16. And if you don't know what exponents are, which is what this is an example of, then you can watch my first number theory video from Meet 1, where I explain how to find exponents, how to use them, and how to write them, and what they mean. But for now, we're just going to assume you know, and 4 to the power of 2 is 4 times 4, or 16. And then you divide that by 8, because that's the last thing you have to do in this parentheses. And 16 divided by 8 simplifies to 2. Next, we have in our other parentheses, 4 to the power of 2 minus 3 to the power of 2. Well, if you remember, I said when anything's in the form of a squared minus b squared, it can be simplified into a minus b times a plus b. Well, this is what we have here in this parentheses, 4 to the power of 2 minus 3 to the power of 2, where 4 would be a and 3 would be b, because they're both being squared and it's one minus the other. So 4 is our a. We can turn this into 4 minus 3, because 3 is our b, so 4 minus 3, times 4 plus 3. And if you don't want to use this trick, you can just simplify it from 4 squared minus 3 squared if you wanted. But this is just a handy trick to speed up the process a little bit. So 4 minus 3 simplifies to 1. And 4 plus 3 simplifies to 7. And then 1 times 7 just simplifies to 7. So right under this, we can write a 7. So this is a 7. And then right here, I'm just going to erase some of this stuff, so I can just write the 2 directly under. So this parentheses simplified to 7, this one simplified to 2. We don't have any more parentheses or exponents, so let's move on. So what we need to do is bring the rest of our equation down so we have it at the same level as what we simplified to. So here we have 45 plus 92 times 2 minus 11 times 7. So our order of operations tells us that we have to do multiplication and division before we do addition and subtraction. Now we have addition and subtraction in this equation. We don't have any division, but we do have some multiplication. So we have to do that first. So first we have 92 times 2, and then we also have 11 times 7. So 92 times 2 is 184, and 11 times 7 is 77. So now we've done our multiplication. So we can bring down the rest of our equation, which is 45 plus 184 minus 77. Now our order of operations has AS, but if you remember what I told you about addition and subtraction and multiplication division, whichever comes first is just the one that you do. So since we have addition first, we're going to do our addition first here, and then 184 minus 77 is our subtraction, so we'll do that second. So 45 plus 184 simplifies to 229. And then we bring down our minus 77, and now we only have one more operation to do. 229 minus 77 leaves us with 152, which is the final answer to 45 plus 92 times 4 squared divided by 8 minus 11 times 4 squared minus 3 squared. So the other thing that you're going to need to know for Arithmetic Meet 1 is about statistics. So just besides solving equations, you need to know a little bit about statistics and how you interpret data, because that's what statistics is all about. So there are a few terms that I'm going to need to teach you and that you're going to need to be able to calculate on certain questions. So in order to demonstrate these terms, I'm going to be using this set of data right here. Now, if you don't know what this is basically, it's similar to a bar chart where you have numbers on the bottom and each X above it represents how many of that number you have. And so this is used in the practical world where, say, for example, you were measuring how many pull-ups each person could do, and you had 12 people. Well, this would represent that one person can do only one pull-up, 4 people could do 2 pull-ups because you have 4 X's on 2, 3 people could do 3 pull-ups, 2 people could do 4 pull-ups, 1 could do 5, and 1 could do 6. And that's how, this is one way of representing data. So the first term that you need to know is the mode. So the mode is defined as the number that occurs the largest number of times. Now the mode is something that we also call a measure of central tendency. It's a way of measuring the center of some amount of data. So this measure of central tendency measures the number that occurs the largest amount of times. Well, if we look at our diagram here, we have 1 1, 4 2s, 3 3s, 2 4s, 1 5, and 1 6. So 2 is the one that appears the most amount of times because we have 4 of them. We don't have 4 of them for any of the other ones. So our mode for this would be 2. So next, the next one that we have is median. So the median is the number where half of the data is larger and half is smaller. It's basically the most middle number in a set of data. So if you're confused on what that means, I'll show you how to find the median, which might help explain it. So you look at your right side and your left side of data, and you cross off pieces of data on each side equally until you meet in the middle. So here I have a 1, and I start on the left side, so I cross this off. And then I have a 6 on this side, on the right-hand side, so I cross this off. Next, I move to my next leftmost piece of data, which is this one, on a 2, and I cross it off. And here I move to my next rightmost piece of data, which is a 5, so I also cross that off. Now on the left side, I cross another X off on 2. On this side, I move to 4 because I don't have any more 5s to cross off, so I cross one of those. And then you keep doing that, so I cross this off, I cross this off, I cross this off, I cross this off, until you meet in the middle. So what I'm left with is crossing this one off, and then crossing this one off. And that's where I met when I was crossing it off, right here, in the middle of these X's. And that is right above a 3, which means that my median for this set of data is going to be 3. And so if that still didn't make sense, it's because if I split the data based off what I crossed off on either side, just like this, on this side of this point, we have 6 pieces of data. And then on the other side of the point, the left top side, where this is the right bottom side, we also have 6 pieces of data. So in the middle of this point, this point is in the middle of the data where we have equal pieces of data on either side. And that's how you find the median. And then I'm just going to clear everything that I did here. So, and then the last one that we have to learn, sorry, not last, second to last, is the range. So the range is not a measure of central tendency. The median is, but the range isn't. It's a measure of how large a set of data is. and is defined as the difference between the largest and smallest number in a set of data. So our largest number in this set of data is 6, and our smallest number is a 1. So the difference between 6 and 1 is 5. 6 minus 1 is 5, and so that gives us our range, which is 5 for this set of data. And then the final one that we have, the final term that they're going to ask you to calculate, is the mean, which we also call the average. And this is also a measure of central tendency. So this is the most complicated one by far. It's the result of dividing the sum of the data by the number of data points. So what I would do here is that I would have to find the sum of all of the data. So what that means is I look at the data and I see how many of each number I have. So I have 1, 1, so I add a 1. Then I have 4 2s, so I add 2 4 times. So 1 plus 2 plus 2 plus 2, and then plus 2. And then I have 3 3s, so I would add 3 3 times, plus 3, plus 3, and then plus 3. I have 2 4s, so I'd add 4 twice. So plus 4, plus 4. I have 1 5, and then I also have 1 6. So 5 plus 6. Okay. So I have to add all of these numbers. Let me put that in parentheses because you have to do this first. So if I add all these numbers, that simplifies to 1 plus 8, because 2 times 4 is 8, plus 9, plus 8, plus 11. I'm just adding different numbers in the parentheses. And then if I simplify that, I can turn that into 37. So this simplifies to 37. And I'm going to actually move that all the way up here because I don't have enough room down there. So this is 37. So the sum of all my data is 37. Now it says it's the result of dividing the sum of data by the number of data points. So I added 12 data points here because I have 1 plus 2 plus 2 plus 2. So that's 5 plus 3 plus 3 plus 3, which is 8, plus 4 plus 4, which is 10 data points, and then plus 5 and 6, which is 12 data points. So my average for this would be 37 divided by 12, because that's how many data points I have. So my final average would be 37 over 12. So I'm just going to talk a little bit more about mean or average calculations, because it's a little bit more complicated than the rest of the measures of central tendency. So if I'm giving you a technical formula to find the mean of a set of numbers, here it is. So if your set of numbers is x1, x2, x3, so on until you have xn, then the mean is going to be x1 plus x2 plus x3 all the way to plus xn over n, where n is the total amount of terms that you have. Now, if you understood that, then awesome. If you don't, then here's an example to explain it. So if here I have a set of data, I have 1, 2, 5, 6, 7, and 9. This is also another way of writing data, just in a little curly brackets. And this is how you signify what numbers you have. Then my pieces of data are 1, 2, 5, 6, 7, and 9. So what I'd have to do is I'd have to add them up in parentheses. 1 plus 2 plus 5 plus 6 plus 7 plus 9. And then divide that by the total number of terms I had. So since I added 6 numbers, I divide by 6. So 1 plus 2 plus 5 plus 6 plus 7 plus 9 simplifies to 30. And if I divide that by 6, which is my total number of terms, that leaves me with 5. So 5 would be the average for this set of data right here. You add all your terms and you divide by the number of terms that you added. So next, if you know the average of a set of numbers, so if they already give you the average, then the sum of all the numbers in the set is going to be n times the average, where n is the number of terms that you have. So in this set of data, I had 6 terms, so n would be 6. And then if I knew my average was 5, then I could do 6 times 5 and figure out that the sum of all the pieces of data will be 30. So let me give you another example. So if the average of 6 numbers is 70, 6 is n, because n is the number of terms, and 70 is my average. If I multiply 6 by 70, then the sum of the numbers is 420, which is just 70 times 6. And then the reason that this is helpful is because if you know what 5 pieces of data are, for example, in a set of 6 numbers, and then you also know the average, you can use this to figure out what they all add up to, and then just subtract the rest of the data until you're left with 1 piece of data. You can use it to find one last missing piece of data in a set of data where they give you the average. So for example, if I knew in this set of data of 6 what 5 of the numbers are, say I knew that 5 of the numbers were 70, 70, 70, 70, and 69, then I could subtract that all from 420, which is the sum of all 6 of them, and that would leave me with 71, which means my last piece of data would have to be 71. So finally, I have a review question to go over mean and median. So if you want to try it, I'll give you a chance to do so. And you can pause the video right now, and then I'll explain it in a few seconds. So the correct answer to this question was $42.50. And in order to solve this question, it says, how much greater was the mean of the prize money than the median? So we need to find our mean and median of this set of data. So right here is our set of data. This set right here. So we need to find the mean and median. I'm going to start with the median. So if you remember our definition of median, it's basically just the center of the data. It's where we have half the pieces of data greater than it and half the pieces of data less than it. So in order to simplify this a little bit more, I'm going to pretend this is represented in a bar graph or an X graph like we had before. So here, if I have $5, then I have $10, I have 20, 50, 500 or 100, 500, and 1,000. Then the amount of X's above each of these would be above 5, I'd have 20 X's, which I'm not going to write out. I'm just going to write a little 20 down here. Above the 10, I would have 10 X's, so I'll just write like a little X 10 here. Above the 5 or above the 20, I would have 5 X's, so I'm not going to write those all out again. Above the 50, I would have 2 X's, so X and X. Above the 10 or 100, I'd have 1. Above the 500, I'd have 1. And above the 1,000, I'd also have 1. So immediately from looking at this, I notice I have 20 X's here. And then I have a total of 10, 15, 16, 17, 18, 19, 20 X's over on this side too. So over here, I have 20 X's total. And then above my 5, I also have 20 X's total. So if I know that both of these have 20 X's total, then my median is going to be right in between them right here. I didn't cross off X's until I got to the median because that would take too long. But remember, the median is just when you have half the data below and half above. So since I have 20 X's here and 20 X's here, that means the median is right in between the 5 and the 10. And the average of 5 and 10, so that's how you find the median. If it's in between two numbers, you find the average of those two numbers. The average of 5 and 10 is 5 plus 10 divided by 2, which is 15 divided by 2, or $7.50. So the median of this data was $7.50. And we're just going to call that the median. So MD, median. And we can't just label it M because median starts with an M and so does mean. So we might get them confused. All right, so next we have to find the mean of this set of data. And I'm going to erase all this in order to have a little bit more space. So the mean of this set of data is going to equal all of the terms added up and then divided by the total number. So since we knew with our median that we had 20 terms on one side and 20 terms on the other, that means we have 40 in total. So we're going to be dividing by 40. So the way to do this is we need to add 5 20 times because we have 20 people who receive $5, and we don't actually have to write out 5 plus 5 plus 5 and so on. We can just write out 20 times 5 because we're adding it 20 times. Then we have 10 people receiving $10, so that's going to be 10 times 10 because we're adding 10 times, plus 5 people receiving $20, which is 5 times 20. Then we're going to add 2 people receiving $50, which is going to be 2 times 50, plus 2 times 50. And then one person receiving 100, one person receiving 500, and one receiving 1,000. So we add plus 100 plus 500 plus 1,000. And there we go. That's our equation for adding them up. And then we just have to divide by 40. So I'm going to put parentheses around this. And then we just need to simplify this addition. So 20 times 5 is 100, plus 10 times 10, which is 100, plus 5 times 20, which is 100, plus 2 times 50, which is 100. See a pattern here? Plus 100, which is this term right here. Then plus 500, plus 1,000. And then if we add the 5 100s up, that gets us 500 plus 500 plus 1,000. And then directly from there, it simplifies to 2,000. So 2,000 is the sum of all this data, or all the money that people got in total. And then if you divide that by the amount of terms, or the amount of pieces of data, which was 40, then that leaves us with 2,000 over 40 as $50 on average per person. And so our average is 50, or our mean is 50. So I'm going to write AVG, that stands for average, is $50. Oops, I forgot to write a little dollar sign here, so I'll do that. And then I'll write one here. So now we have both our average and our median. And the question asks, how much greater was the mean of the prize money than the median? So all we have to do is subtract $7.50, 750 from 50. So it's 50 minus 750. And I'll write it out like this because it's some amount of money. And that subtracts to $42.50. So $42.50. So final review question for Arithmetic Meet 1. It's about averages and means. And if you want to try it, I'll give you a few seconds to pause the video, and then I'll go ahead and explain the answer. So the correct answer to this question was that Sly got a 93 on his test. So let's read the question. Sly knows his quiz scores were 92, 85, 96, 82, 88, and 91 for the first quarter, but he can't remember what he got on his final test. He noticed that his overall grade, which is the average of all his quiz scores and tests, is exactly 90. If a test counts as 2 quizzes, then what does Sly get on his test? So they tell us that the average of all his quiz scores and tests is exactly 90. So we already have a measure of central tendency here. We know that the average of the set of data, which are his quiz scores and his test, is 90. And it's asking us, what did he get on his test? So we need to be able to use that in order to find the value of his score of the test. So if you remember back to when I was talking about mean or average specifically, you can find the value of the sum of all the pieces of data in a set if you know what the average is and if you know how many pieces of data there are, because that's only the average, which is 90 in this case, times the amount of pieces of data. So in this case, we have 8 pieces of data total that we're multiplying by, because we have 6 quiz scores, a 92, 85, 96, 82, 88, and 91. And then we also have 1 test score, which you might think would add up to 7, but in this case with the data, we're going to count it as 8, because the question tells us that a test counts as 2 quizzes. So if we're counting 1 quiz as 1 piece of data, since a test counts as 2 quizzes of data, or 2 quizzes, then a test also counts as 2 pieces of data, which gives us 6 quizzes plus 1 test, which is 2 pieces of data, and that's 8 in total. So 90 times 8 is 720. So 720 is the sum of all the pieces of data for this set. So in order to find what the value of his test score was, we just have to subtract all of the other quiz scores from 720 and then divide that by 2, because that will give us the value of 1 test score. So 720 minus 92, then minus 85, minus 96, minus 88, minus 82, and go in order, and then minus 91 is what we have to do to the 720. Okay, and now we have our expression here. So all we need to do is simplify this. So this all simplifies to 186. The 720 minus all of these pieces of data is 186. And so you can't stop there because obviously Sly didn't get a 186% on his test. That's just completely absurd. And I already told you the answer was 93, but you wouldn't know that if you're just trying this question on your own. So what we need to do now is divide 186 by 2, and here's why. Because from 720, we subtracted 6 pieces of data, but we multiplied 90 by 8 pieces of data, which means what we'll be left with is considered as 2 separate pieces of data. So in order to find the value of one of them, and they're going to have the same value because they're just representing a test score, we just need to divide by 2. So 186 divided by 2 is 93. So Sly got a 93 on his test. So just to quickly go over what we learned today, we started and ended the arithmetic section. And we learned about the order of operations, which is the order that we do operations in an equation, which is PEMDAS, stands for parentheses, exponents, multiplication and division, and then addition and subtraction. And a good mnemonic to remember that is please excuse my dear Aunt Sally. And so one important note about PEMDAS is that multiplication and division technically have the same priority, and so do addition and subtraction. They're all equal in order. Well, the 2 and 2 are equal in order. So whichever comes first is what you do. You don't necessarily do addition before subtraction. You don't always do multiplication before division, just whatever comes first out of them. And then we used an example to demonstrate this. Next, we talked about 2 tricks to simplify solving. The first was grouping, which is when in an equation we look for alike terms and just combine the operations done on them. So these alike terms are 34 plus 5 and is being multiplied by 83 and 917. So we just added 917 and 83 and then multiplied that by 34 plus 5. And that made the question a lot easier because we just had to multiply 39 by 1000. And then we also talked about square terms, how when an equation has a squared minus b squared in it in parentheses, so 2 numbers are being squared and one is being subtracted by the other, it can be simplified to a minus b times a plus b, or one number minus the other times that number plus the other. And then this was our example. When we have 27 squared minus 23 squared, it can be simplified to 27 minus 23 times 27 plus 23. And then to go over the order of operations, we did a practice question where we got the answer as 152. Then we talked a little bit about statistics, which is the other thing we need to know for Arithmetic Meet 1, and use this set of data to demonstrate the terms. The first was mode, which was the number that occurs the largest number of times in a set of data. So for this set of data, it's 2 because we have 4 2s in it. So our mode would be 2. The median was the number where half of the data is larger and half is smaller. It's basically the most middle number in a set of data, and we found by crossing off x's until we meet in the middle that the median for this set of data was 3. The range was the difference between the largest and smallest number in a set of data. So 6 minus 1 is 5, and since 6 is the largest and 1 is the smallest, 5 is our range. And then finally, the mean, or also known as the average, was just the result of dividing the sum of all the pieces of data by the number of data points. And I think the average for this set of data was somewhere around 3.06. And then for mean and average calculations, we talked a little bit more about that. We actually got a formula for the mean of a set of numbers, which is just when you add the numbers and divide by the total number, like this. So we added 1, 2, 5, 6, 7, and 9 when we had those as our pieces of data, and divided by 6 because that's how many terms we added to get 5 as our average. And then we also talked about how if you know the average of a set of numbers, but you don't know all of the numbers, then you can use the sum of all the numbers, which is n, which is the number of terms that you have, times the average, to find the last number in that set. So for example, if the average of 6 numbers is 70, then the sum of all the numbers in that set is 70 times 6, or 420. And then finally, we did 2 review questions, one where we found both the median and average, and then the difference between them, which was $42.50 in this case. And then we did one more where we had to use that rule where we know what the sum of all the data was if we know what the average is and how many terms there are, to find that Sly got a 93 on his test. So that's it for the arithmetic section for Meet 1. It is a really short section because it's all just based around solving equations and then a little bit of statistics. But I hope this was helpful, and I hope you can apply this into your IMLEM solving.